Welcome to this week's training session. This week we're going to be looking at a few business layer fundamentals, and we're also going to take a look at a few helpful little hints and tips that we've accumulated over the years working with the business layer and with scripts in particular. So today we'll start off looking at return values, and anyone who's spent any time training with us before will no doubt have drummed into them the importance of checking return values in FinPower Connect. So by return values, we simply mean that most of our business layer functions, anything that basically is going to save, load, execute, get, any of those functions, I guess, that are a verb, will return a Boolean. And that gives us the means to check whether that function has been successful or has failed. So you can see straight away, just by popping the template code into a general script, we straight away get our main function, which is a Boolean. And this is basically the standard by which all of our business layer functions are written. In a very similar way. So we have our main function, this returns a Boolean. You can see here the very first thing we do is we assume success, we say main equals true. Therefore, if we run that script is executed successfully. Main is true, everything's happy. If we set main to false, okay, now there's been an issue, and therefore the script has failed. So what's important while we're working our way through the business layer is to understand why we have our functions as return booleans, and how FinPower Connect traps those errors in the background. We're going to do another session in the future with looking at error handling in particular, but the two kind of do go. They may not necessarily go hand in hand, but they do have an impact on one another. So here we can see we have our account object. We create our account object. Now create account. And we have a look on our account object, and we can see when we go to load an account, we can see here that the load function returns a Boolean. So as I say, a really good rule of thumb, and it's not necessarily a 100%, but 99 times out of 100, if the function is a verb, it's a load, it's a save, it's a get, it's an execute, then 9 times out of 10 it's going to return a Boolean, and it's really important that you check that Boolean. Okay, if we do give an example here where I'm going to load a account that doesn't exist in this database, and I don't check my return value, so I'm just going to say account.load, script executed successfully. So to the end user, even to yourself, it looks as though there's no issue with this script whatsoever. It's absolutely happy. It's gone ahead and it's loaded account, whatever that garbage string is. Okay, of course it hasn't. And behind the scenes, if we look in our debug window, we can actually see down here that it's failed to load that account, and it's recorded an error in the business layer. Okay, it's not going to display that error until we set main to false, because we saw that earlier. We set main to false, and it will fail the script. Okay, so it doesn't know to return an error to the user to say that this account has failed to load, because we haven't handled the Boolean. Okay, so we've just said account.load, happy days, it's absolutely happy. Main is still true, therefore the script is still correct. The script is still going to finish, and as far as the script is concerned, there's no problem, even though behind the scenes FinPower Connect has failed to load the account. Okay, so straight away you can see it's really important that we need to check that load has actually been successful. We can do that just by simply setting main, which is a Boolean, to equal the result of that load. Okay, so if that load is false, then main becomes false. If that load is true, then main becomes true. Now if we run it, here we go, and we get our FinPower Connect error message. So this is the other thing to understand with FinPower Connect, is not only will it know whether that load has failed or succeeded, but if it has failed, it will have a meaningful error message. and it will have built that error message and it will have stored that error message. By setting the script to fail when the account load fails, it will automatically display that error message to the user. We don't need to do anything else. We don't need any extra error handling or anything. Okay, it's going to display the message failed to load the account, record not found, and that's all the information that we need. Okay, if we were to do this for an account that does exist, script successfully executed. Okay, so really important to check the result of any function that returns a boolean. If it returns a boolean, just check to see whether it's worked or not. It's a really simple and fundamental part of coding in the business layer, and any coding in a tool. In fact, if it returns a true or a false, then you really need to check to see whether it's actually worked or not. Okay. So that's what we mean when we say return values, and as I said before, you'll notice that all of our load and save functions all return booleans, okay? And they must be checked, and we can't stress that enough, because if you do not check your return values, then you're going to have a devil's own job debugging your script and finding out where things are failing if your script's telling you everything's worked all the time when it hasn't. Okay, so you can imagine in this scenario, obviously this is only a few lines long, but when you've got a script that's a few thousand lines, you haven't been checking any of your return values. It could have been failing anywhere through your thousands of lines of code, and you're going to have real trouble finding where it's failed. So we would simply set main equals account.load, and then if that's worked, if main, then do stuff. Okay, so that is the way that we typically would structure our scripts. We'll use our load function. We'll check the return value to see whether it's worked or not. If it's worked, then we'll carry on. If it hasn't, then it won't go in and try and do any of the rest of the stuff. And that's the other reason, obviously, for checking the return value, is if you said simply set account.load, and then you've gone on to say do stuff here, it's going to try and do a whole bunch of stuff with an account that it hasn't actually managed to load. So you're then going to get a whole bunch of other errors. Okay, so again, can't overemphasize the importance of checking those return values. I will bang on about it all day long because it's really important, and it makes your life and our life an awful lot easier when it comes to debugging scripts. To know when things have failed and that you're handling those failures. So as I say, you can forgive me for going on and on about it, but it's basically the first thing that we drum into any new member of staff here is you check your return values, and that's as I say, fundamental to the business layer, and probably the number one thing. If you don't take anything out of any of these training sessions, then take that out. Okay, so moving on. So we've looked at return values. We're going to take a quick look at global collections now. So global collections, broadly speaking, would be anything that hangs off the admin menu. These are all global collections, okay? Or rather, we have global collections of all of these things, plus some others, but majority, when we talk about global collections, we're meaning account types, branches, etc., etc. We can access our global collections just via the business layer, so fimbl dot, let's use account types as our example, fimbl dot account types. Now that collection of account types holds every single account type that is in your in this list of account types. Okay, so it holds read-only versions of all of these. So you can't use a global collection to update an object. So we can't update an account type using a global collection, but we can get values from it. And this is really important because global collections actually get loaded into memory when FinPower Connect loads. When any of the global collections are changed, so if anyone goes in and makes a change to the account types in the admin menu, those global collections are refreshed, so we always get the latest version of the object that we're looking at, in this case an account type. And because they're loading into memory, it makes it really, really fast to access them. So rather than having to load an account type from the database to go and get the interest rate, we can simply go straight to global collections, avoid a hit to the database, and go straight to memory and go, give me that account type. Okay, and accessing memory is infinitely faster than accessing information via the database. So wherever possible, whenever you need a field from an account type, you need a field from a branch, you need a field from an external party, or from a product type, or whatever it may be, from your workflow types, then you should be accessing those via global collections and not loading via the database. Okay, so if we take a look at account types as an example here, so if we can look at account types.item, and that item accepts a key, which is your account type ID. We'll look at CC, and it loses IntelliSense here, so we'll just go back just the other side of the brackets just so that you can see what's available from the read-only account type object. So this is our CC account type we're looking at now, and these are all of the fields that we can get from that account type. Okay, so we can go down here and we can see all of our interest options. We can get our interest rate, which is what we'll do. And we'll debug this to screen. Oops. Okay. That's because I'm in an Australian database and we don't have a CC account type. And there we go. Okay, so that's returned our 20% from our CC NSW account type. Okay, so let's just grab that field there. So we've managed to go and grab that interest rate field and display that interest rate field without having to hit the database at all. Okay, so it's really, really fast. We can achieve the same thing by loading an account type object. Oh, I should probably learn some editing skills so you don't have to sit and watch me mistype. So we can achieve the same thing by loading an account type.load. Okay, and then we can access that account type's interest rate as well. But that's going to be a much slower way of getting the information that we need. We can get the same thing with a one-line call there. finbl.account-types item that dot interest rate. Simple, and it's much faster. So be aware that these global collections exist, and as I say, we're looking at branches, external parties, workflow types. All of these global collections are loaded into memory and are accessible at any time, and it's always as I say, anytime those are updated via the admin menus, the global collection is refreshed. So you're always getting the latest versions of the objects. Now, because they're read-only objects, you can see here that this is a read-only account type. So it's a fin account type RO, which defines a read-only object. It doesn't have every single field available. Most of the fields that you see on the account type screens will be available, but some aren't. If you come across a field that it's not available on the read-only object, which is fairly uncommon, then by all means let us know, and we can request that be added so that it's available via the global collection. And lastly, just to re-emphasize again that global collections, they're loaded into memory, but they're all read-only, which means you cannot affect a change to this account type. We can read back the interest rate, but we can't set the interest rate by using the global collection. If you want to set the interest rate, then you obviously have to load that record from the database, make the interest rate change, and then save it back to the database. So these are for read-only purposes only, but for things like documents and scripts in general, they are incredibly useful. And again, things like documents. global collection of documents, etc., etc. One other thing to note here is we've hard-coded our CCNSW account type here. Typically, before we go to use that, we would do a check to make sure that that item actually exists. So each of the global collection has an exists function, which again accepts the key, which will just be our account type code in this case. FinBR.account type exists, then we'll go and use it. So again, that's a really crucial thing to understand when using global collections. If you're going to pass in a code, and typically we wouldn't be hard coding this. We don't hard code values in our scripts. Okay, that would live as a constant. But by way of validating that the user has set the correct constants, the correct constant values, we would do a check on exists first to make sure that that record is valid before we attempt to use it. Okay, so that's global collections. And the last one we'll look at is global constants. Okay, so under tools and global settings, you can see under the general tab here, the general ribbon, we have a constants page. So these constants are global constants that can be used in scripts and documents and workflows and wherever else we can use scripting. And they work in exactly the same way as script constants do. The script constants are obviously restricted to the script, so you can access the script's constants via using the script info object. But the global constants apply more broadly across the database. So basically, if you've got a value and you need to be able to store it at a global level so that you can access it from a number of different scripts or a number of different workflows or whatever, then a global constant is probably where you're going to want to store that value. So good examples of things that we've used global constants for would be accessing external APIs. So if calling some other system somewhere, passing information from FinPower through to another system, we might store things like the URLs and any authentication details for that API as global constants, and that way they can be used across however many scripts that are punching stuff over to that other system. So global constants really useful. Can add a global constant. Like I say, they're exactly the same as script constants in terms of creating them. That now lives globally in memory in the global collections. Okay, and via a script we can access that using the business layer FinBR.settings, which is our global settings. Obviously, user preferences, user settings are settings user. FinBR.settings, that's our global settings .constants, and we access these in exactly the same way we would do a script constant. So constants.getString, we know obviously you need to know what type the global constant is first. So you'd go to global constants and check. We've obviously just created ours, which had a key of test, and it was a string. So again, if I use our debug here, you can see therefore that's returned the value from our global constant. So again, just in the same way that we have our script constants available to us, we also have the concept of more global constants. And as I say, these are particularly handy where you have a constant that may be applicable to more than one script or more than one workflow report template or whatever. Rather than having to maintain that constant across a number of places, you can store that as a global constant and access it from the script. Okay, so this session's gone on a little bit longer than intended because I spent so long drilling home the importance of return values. So next time we'll pick up and look at some little helper functions and things that we've accumulated over the years in our next session, as well as taking a look at some of the debug options that we have available in FinPower Connect, and a bit more of a look at the business layer help as well. Thanks very much, and see you next time.